Hello everyone, and a very warm welcome to the final part of this mini-series. This is part 4 where we are going to be exploring the hybrid case, which is essentially the complete fusion of both case 2 and case 3. I'd recommend, as always, watching the previous parts, especially since in this part we'll be reusing what we did in case 3, which was the actor with physics and light, and we'll implement case 2 to make it persistent. Here on the map, I've already taken the liberty of placing 3 actors. Alright, to begin, we need to adapt our actor. For that, it's quite simple. First off, we're going to give it an index, as always, and then we'll activate the instance editable. It's very important to remember that index 0 will be reserved for actors created at runtime, and then indexes 1, 2, 3, and 4 will be used for our persistent actors. In the event that we use an fquid, which is a deterministic identifier, what's going to happen is that we're going to say, well, the 000, when the ID is all zeros, meaning the guide is entirely zeros, it signifies that it's created at runtime. The same principle applies here. In our specific case, because we won't be using a deterministic ID due to time limitations, we are going to define 0 as an actor generated at runtime. This will become much clearer once we've completed the integration and observe precisely how it integrates into the save actor, into the save manager. But everything in its own time. I also took the liberty of going to the save folder to save actor data and creating this. We click add, then add function, then load light sphere, which only has a single Boolean variable called light status. This will be quite useful for us because now we're going to combine the existing logic of our runtime actor with the new logic that we'll be building for our persistent actor. The very first thing we do is the same as always. We are going to place a not Boolean node, we connect our Boolean variable to it, and then we're going to call the interact event, which is this specific event right here that actually changes the color of the light. The not Boolean node is used to correct the logical state. Alright. With this, we've completed the first part. Our actor should now be fully finished. The next thing we need to do is prepare our data structures. We're going to navigate to the fmaster data, then add a new variable and we'll name it light sphere persistent. That's perfect so far. We're going to generate, it's going to be an integer variable type and the container will be a map. Here we're going to put flightsphere, we'll save it, and we already have the structure generated as well. Alright, next up, we're going to head over to the save manager now. Before we begin, I really want to clarify a very important concept. This was actually something that was missing from the previous tutorials, and it's quite important to understand. Here, once we've successfully completed the save success, we absolutely need to set the master variable right after the print stream, specifically when it returns true. Why? Because that's how we empty the variable. And what's the real benefit of emptying out this variable? Firstly, we're going to consume much less RAM because all that data was erased, it simply ceased to exist, and the second important thing is, this is how we avoid future conflicts. For example, if we click the load button 1,000 times, we might frequently reload a variable from an array and then completely forget to clear it. So, this causes those data to be deleted by configuring it this way. And the same goes for the load. When we perform a load, what we must do here is, at the very end of the entire chain, ensure that it's emptied. If we were to create another object, the function would be placed in between these two, and this part always goes at the very end. Why is that? Because if we were to put it earlier, we'd delete it. I mean, we would erase the data before using it. Then it simply wouldn't make any sense. It always has to go at the very end. Alright, and now that this has been explained, let's go to the save. Okay, to start, we'll get that ID we reserved as 0. We'll perform a get index and check for equality. If it's equal to 0, we'll proceed with the array's path. We're going to take the array route. Now, if the ID is not equal to 0, we're going to add a find, and we're going to add, not a find, we're going to add a map, we'll connect it to false, and we're going to connect the index. Well, the next thing is to connect the data. The basic is to connect light status, which are our variables. If we had 10 variables, it's the same. We'd put all 10 here and connect all 10. Now the class isn't connected in this case, because we already know the actor will get later. So, what we are definitely going to connect is the transform of the sphere. Why is that? We need the transform for the actor's position, and this is solely because the actor has physics. If this were a chest that doesn't move, it wouldn't be necessary to give it a transform. We wouldn't connect a transform to it because the actor will always remain there as it's persistent on the map and doesn't move. But since it's a physics actor, we're going to connect its transform, so that the transform of this particular sphere persists. And with this, we would have the entire save function completely finished. Now let's move on to the load function. For the load function, here again, we'll need to use the index. For what purpose? For the destruction, 1000, we go here, equal to 0 branch. Why for destruction? Because we have our persistent and runtime actors. So what could happen to us in the game? If we press the button and this check isn't there, we would delete the persistent and runtime actors, and we don't want to delete the persistent ones.
Well, then in this section below, we're going to put a sequence.
And the sequence, the array part, it must be a single unit. Why must it be a single unit? First, because we must remember that the sequence executes in order. First, it will execute 0, then it will execute 1. And if there were 2, it would execute 2, 3, 4 in sequence, as the name implies. What happens? We first want to load the data into our existing persistent actors and then generate the runtime ones, not the other way around, because it's not useful for us to do it in reverse. Therefore, what we are going to do right now, once we already have this in place, is to say, alright, we're all set with that. We can then place our master data here. We're going to put the persistent, we're going to put defined, and here we're going to do a get all actor of class, as always BP.
Light sphere for each loop.
And over here, we're going to create a get index, and then we'll connect that directly to the find operation. That's absolutely perfect. After that, we'll go ahead and create a new branch right here. Well, actually, no, not the branch just yet. First, we're going to do a set actor transform. So, next up, what we're going to do is we'll be creating a load light sphere as a method. And then, finally, at this point, yes, we're going to insert the branch right here in the middle of everything. Alright, so here we'll make a break and connect transform here and light status there. We'll arrange it, and now everything is finished here. All the logic is now complete. What's left is to place the actors on the map. I've put 3 here and assign them their identifiers. Let's put it in, I'm just moving around all over the place. 1, 2, 3. So then here we have 1, 2, 3, and we've already got 3 generated persistently. We're going to spawn a couple. Yeah, and we're going to place this green one, and this green one. We're all going to press 3 to save. And there, we see it's saved. I'm going to hit escape. I'm going to hit load. And we see that the actors are in the same place where they were. Well, we see that the actors, again, are where they should be. They don't duplicate, and it works. Perhaps the most crucial and equally important point of this entire video, going beyond just the operational aspects of case 4, is to always remember, and this is truly paramount, the matter concerning the garbage from, well, here Unreal is crashing on me, as it always does, for absolutely no discernible reason, but that point I made earlier, it's really quite important about emptying out the trash. It's truly essential to empty out the garbage from the... It's very important to take out the trash here, things that we're not using. But anyway, we can see that even after my editor crashed and I open it again, when I go to load it, since the data is saved, it loads. And so, if we go to the database, we can see that we have 3 elements here, 3 array elements. If I were to generate a couple more and then hit save, we'd obviously see that the array elements are now more numerous. Alright, so with that, the tutorial ends and the mini-series. Thank you very much to everyone who watched, and if you have any questions, you can always message me on Discord. The link will surely be in the description. Alright, thank you very much.